Something extraordinary just happened, and it could change everything. Elon Musk has dropped the most shocking robotic update of 2025, and it's turning the tech world upside down. While everyone was distracted by flashy robot demonstrations and viral dance videos, Boston Dynamics just unleashed something that changes everything. The new Atlas robot isn't just moving differently, it's actually thinking, adapting, and solving problems in real time like never before. What happens when you give a robot a brain? Unitree's G1 Humanoid just found out, and it's changing everything we thought possible in consumer robotics. But Unitree isn't alone in this race. Lenovo is stepping into the humanoid arena with surprising ambition, and China is preparing to host the first ever Robot Olympics. This isn't just progress, it's a turning point in the evolution of robotics, and it's unfolding right now. The game-changing brain, AMO. So what we're saying was that Unitree's G1 humanoid robot just received a revolutionary upgrade called AMO, or Adaptive Motion Optimization. This isn't just a software update, it's essentially giving the robot a brain that understands how to move like a living being. What makes AMO special? Most humanoid robots struggle with complex movements because controlling 29 degrees of freedom while maintaining balance is incredibly difficult. Traditional approaches used rigid control systems or pre-programmed motions that couldn't adapt to real-world environments. AMO changes everything by combining reinforcement learning with trajectory optimization. The system runs millions of simulations, allowing the robot to fail repeatedly without physical damage. It learns to pick up objects from the floor, reach high shelves, twist its torso, and crouch all without losing balance. These lessons then translate into real-world behavior that works not just in controlled environments, but in your actual home. When you see the G1 bend down to grab a toy, or carefully adjust its balance to place a bottle on a high shelf, that's AMO in action. It's controlling the robot's entire body, legs, torso, waist based on an internal plan, not just isolated joint movements. And it does this in real time, responding to environmental changes and adapting to unpredictable inputs. What's truly remarkable is the teleoperation capability. You can control G1 using a VR headset and it'll mirror your movements. But here's the magic. When you let go, it doesn't freeze. It understands the goal and continues executing the task, smoothly transitioning from human guidance to autonomous action. Under the hood, AMO uses a hybrid motion synthesis pipeline that blends human-like arm movements from motion capture data with sampled torso commands. This generates entirely new kinds of whole-body actions that weren't even in the original datasets. The robot isn't just imitating, it's generalizing. For example, G1 doesn't rely solely on waist motors to tilt its upper body. Instead, it shifts its legs, bends its knees, and uses full-body posture to reach angles that previous robots couldn't attempt. There's extensive work behind the scenes to ensure this control works out of distribution, meaning G1 can handle commands and situations it never encountered during training. In testing, G1 performed tasks like picking up baskets from floor level, walking forward, and placing them on eye-level shelves. This kind of full-body coordination from crouching to twisting to reaching to placing used to be science fiction. AMO makes it routine. Now, if you are shocked with this news, make sure to watch how China has already introduced Robocops to their public. Meet Optimus Gen 3, the humanoid robot that can now dance, balance on one leg, and perform complex household tasks with uncanny human precision. Musk has confirmed these humanoid machines will be available to buy by Q4 2025. But here's the twist. This isn't a minor evolution. This is the world's first truly autonomous humanoid robot. To understand just how revolutionary Tesla Bot Gen 3 truly is, we need to look at what separates it from both its predecessors and every other humanoid robot currently in development. When the first Optimus prototype debuted in 2022, critics were quick to dismiss it as nothing more than an expensive tech demo. The robot could barely walk in a straight line, and its movements were rigid and pre-programmed. Fast forward to 2025, and we're looking at a completely different machine. The most striking difference lies in Optimus Gen 3's dynamic real-time control system. While previous versions relied heavily on pre-programmed movements and basic servo motors, Gen 3 operates through what Tesla engineers call simulation-first learning. Every movement is refined within Tesla's Dojo supercomputing environment, where reinforcement learning teaches the robot how to shift its center of gravity and adjust joint torque using feedback loops accurate to the microsecond. Compare this to Boston Dynamics' Atlas, which, while impressive in its parkour abilities, still requires extensive pre-programming for each specific task. Honda's Asimo, once considered the pinnacle of humanoid robotics, looks positively primitive next to Optimus Gen 3's natural movement patterns. Even more recent competitors like Figure 02 and Digit 54, while capable in their own right, lack the seamless integration of AI learning and real-world adaptability that Tesla has achieved. Just this week, Boston Dynamics revealed that their latest Atlas humanoid has been equipped with a perception system so advanced that it can work through complete chaos, fix problems on the fly, and even learn from mistakes without any human intervention. We're not talking about pre-programmed movements or carefully choreographed demonstrations anymore. This is a machine that can literally think its way through unexpected situations, and the implications are absolutely mind-blowing. But here's what makes this even more incredible. While competitors like Tesla's Optimus are still struggling with basic walking patterns and China's most advanced robots require constant human oversight, Atlas has achieved something that seemed impossible just months ago. It's operating with what engineers are calling athletic intelligence, the ability to perceive, think and act with the fluid adaptability we've only seen in biological systems. So in this video, I'm going to break down exactly what makes this new Atlas so revolutionary, show you the 5 breakthrough technologies that are powering its artificial brain, and explain why this represents the biggest leap in robotics since the invention of the computer. Trust me, by the end of this video, you'll understand why we're witnessing the birth of truly intelligent machines, and why the future just arrived faster than anyone expected. To understand just how revolutionary this new Atlas really is, we need to look at the incredible journey that brought us here. The original hydraulic Atlas that captured the world's attention was essentially a mechanical marvel, incredibly strong, surprisingly agile, but ultimately limited by its reliance on pre-programmed movements and hydraulic systems that were loud, messy and energy-hungry. That hydraulic Atlas could perform backflips and navigate obstacle courses, but every movement was carefully planned and rehearsed. It was like watching an incredibly talented athlete perform a routine they'd practiced thousands of times. Impressive? Absolutely. But truly intelligent? Not quite. The new all-electric Atlas represents a complete philosophical shift in robotics design. Instead of building a machine that executes pre-planned movements, Boston Dynamics has created a robot that can perceive its environment, understand what it's seeing, make decisions about how to respond, and then execute those decisions with precision that rivals human capability. This isn't just an upgrade, it's a fundamental reimagining of what a robot can be. The new Atlas weighs 89 kilograms, stands with perfect posture, and moves with a fluidity that makes its predecessor look robotic by comparison. But the real magic isn't in its physical design. It's in the artificial brain that's processing information and making decisions faster than human thought. The viral video that captured global attention shows Optimus Gen 3 performing what can only be described as a masterclass in dynamic balance. The robot executes coordinated spins, jumps, and fluid dance motions with no external support whatsoever. But this isn't just entertainment, it's a demonstration of technological capability that has profound implications for real-world applications. What makes this even more impressive is that Tesla engineers confirmed the robot was operating in what they call blindfolded mode during portions of the demonstration. This means Optimus wasn't relying on its visual cameras to maintain balance and execute movements. Instead, it was using proprioceptive sensors throughout its body, much like how humans can maintain balance with their eyes closed by relying on inner ear feedback and muscle memory. Milan Kovac, a Tesla engineer working directly on the Optimus project, revealed that these movements were entirely learned in simulation and transferred to the real world with zero additional training. This sim-to-real pipeline represents a breakthrough in robotics that could revolutionize how we develop and deploy autonomous systems across countless industries. Now, if you're interested enough to learn more about how Tesla Optimus Gen 2 was already superior to another AI robot such as Figure 2, then make sure to watch the video shown on your screen. What makes this new Atlas truly special lies in 5 breakthrough technologies that work together to create something approaching genuine artificial intelligence. These aren't just incremental improvements, they're revolutionary capabilities that transform how robots interact with the world. The first breakthrough is real-time object detection that goes far beyond simple recognition. Atlas can identify objects, obstacles and hazards in its environment while simultaneously understanding their properties, dimensions and potential interactions. When Atlas looks at a factory floor, it doesn't just see shapes and colours, it understands that this object is a shelf, that component is a car part, and this area represents a potential hazard. But here's where it gets really impressive. Atlas can do all of this processing in real time while maintaining perfect balance and executing complex movements. The robot's vision system operates through lightweight neural networks that deliver instant recognition without sacrificing accuracy or speed. The second revolutionary capability is three-dimensional fixture localization. Atlas doesn't just see objects, it understands exactly where it is in relation to everything around it with millimeter precision. When working with automotive parts that require exact placement, Atlas can maintain positioning accuracy within a 5 centimeter margin, even when the entire work environment is shifting around it. During recent demonstrations, engineers deliberately moved shelving units while Atlas was working. Instead of failing or requiring reprogramming, the robot paused for a fraction of a second, recalculated its position relative to the new environment, and continued working as if nothing had happened. This kind of spatial awareness and adaptability was impossible just a year ago. The third breakthrough technology is what Boston Dynamics calls super tracker object pose estimation. This system allows Atlas to understand not just what objects are, but exactly how they're oriented in three-dimensional space. When Atlas picks up a complex automotive component, it instantly understands the object's weight distribution, optimal grip points, and how to manipulate it for precise placement. This capability extends to handling objects that Atlas has never encountered before. The system can analyze new objects in real time, determine their properties, and figure out the best way to manipulate them without any prior training or programming. The fourth revolutionary technology is hand-eye calibration that operates with superhuman precision. Atlas can coordinate its visual perception with its physical movements to achieve accuracy that exceeds human capability in many tasks. When placing automotive parts into precise slots, Atlas maintains positioning accuracy within 2 millimeters, a level of precision that would challenge even skilled human technicians. This isn't just about steady hands or good eyesight. Atlas is processing visual information, calculating optimal movement paths, and executing precise manipulations while constantly adjusting for variables like lighting changes, surface irregularities, and unexpected obstacles. The fifth and perhaps most impressive breakthrough is adaptive error correction. Atlas doesn't just detect when something goes wrong, it learns from mistakes and adjusts its behavior to prevent similar problems in the future. When an object doesn't fit properly, or a movement doesn't achieve the desired result, Atlas analyzes what went wrong, develops alternative approaches, and implements solutions in real time. During one demonstration, an engineer deliberately dropped a heavy automotive part behind Atlas while the robot was working. Atlas heard the sound, turned to investigate, located the fallen part, analyzed its orientation, figured out the optimal way to pick it up, and placed it correctly, all without any human instruction or intervention. How does AMO compare to other systems? Coming back, detailed evaluations comparing AMO to older control strategies showed it outperformed everything else across the board. Even when pushed into untrained territory, AMO showed minimal tracking error. In trash-throwing tasks, it smoothly twisted its torso 90 degrees and nailed the throw. In another setup, it picked up a paper bag by aligning its torso, maneuvering its hand through the loop, then lifting and placing it without losing grip or posture. The training process is equally impressive. AMO uses a two-stage learning framework. A teacher policy with access to ideal data, followed by a student policy learning in a more restricted setup, mimicking what the robot would experience in the real world. This approach allows the final system to perform reliably without perfect conditions. The result? G1 with AMO isn't just reacting, it's planning, adjusting, and executing complex tasks that most robots still struggle with. It stretches, crouches, twists, walks, and balances while coordinating all 29 joints across its body. And instead of the mechanical stiffness we usually see in robots, G1's movements feel smooth, deliberate, and surprisingly human. This is where humanoid robotics is heading. Not just mobility, but full-body dexterity with responsiveness that makes real-world deployment finally possible. Unitree didn't stop with humanoids. They've also transformed their B2 quadruped robot into a specialized firefighting machine. This modified version comes equipped with a water or foam cannon capable of shooting up to 60 meters away at 40 liters per second, powerful enough for serious emergency response. The firefighting B2's joints are upgraded by 170% over the standard model, allowing it to climb obstacles up to 15 inches high and handle steep stairs at a 45-degree angle, perfect for navigating damaged buildings and chaotic disaster scenes. But it's not just about raw power. The B2 firefighting dog is packed with technology: live video feeds, LiDAR sensors, and communication equipment for sending real-time updates to human teams. It features a built-in cooling sprinkler system to survive extreme heat, plus swappable batteries that maintain waterproof integrity. This machine is designed to go where humans can't collapse buildings, toxic environments, zero visibility areas. It can map surroundings, locate fires, carry specialized modules, and support rescue operations without putting human lives at risk. Beyond the impressive demonstrations, Optimus Gen 3 has been quietly mastering the mundane tasks that actually matter in daily life. Recent footage shows the robot performing household chores with remarkable dexterity, picking up trash bags, opening cabinet doors, cleaning tables, tearing paper towels from rolls, stirring pots, and even operating a vacuum cleaner. These might seem like simple tasks, but they represent enormous technical challenges. Each action requires the robot to understand object properties, apply appropriate force, and adapt to unexpected variables. When Optimus tears a paper towel, it must gauge the exact amount of pressure needed to separate the sheet without tearing the entire roll. When stirring a pot, it needs to understand viscosity, temperature, and the appropriate stirring pattern for different types of food. The robot's hands deserve special attention. Optimus Gen 3 features 22 degrees of freedom in its hand design, allowing for incredibly precise manipulation of objects. It can handle delicate items like eggs without breaking them, yet apply enough force to lift heavy objects weighing up to 20 kilograms in each arm. This versatility comes from advanced tactile sensors that provide real-time feedback about pressure, texture, and object stability. Perhaps most importantly, Optimus Gen 3 can navigate uneven terrain autonomously. In demonstrations, the robot successfully traverses grass, gravel, and stairs without any remote human control. It uses sensors in its feet to analyze ground conditions and adjusts its gait accordingly, much like how humans automatically modify their walking pattern when moving from pavement to sand. At the heart of Optimus Gen 3's capabilities lies Tesla's integration of automotive AI technology with advanced robotics. The robot uses the same neural network architecture that powers Tesla's full self-driving system, adapted for bipedal locomotion and manipulation tasks. This gives Optimus a significant advantage over competitors who are building their AI systems from scratch. The robot's brain consists of a custom AI chip containing trained neural networks that process sensory input and make real-time decisions. Optimus is equipped with multiple cameras, ultrasonic sensors, and proprioceptive feedback systems that create a comprehensive understanding of its environment. This sensor fusion allows the robot to build detailed maps of its surroundings and remember environments for future interactions. Power management represents another crucial advancement. Optimus Gen 3 operates on a 2.3 kilowatt-hour battery pack that provides up to 10 hours of continuous operation. The robot's power consumption has been optimized to just 1.6 kilowatt-hours under normal operating conditions, making it incredibly energy efficient. At current electricity rates, operating Optimus costs less than 30 cents per day. The physical design emphasizes both durability and human-like proportions. Standing 1.73 meters tall and weighing approximately 57 kilograms, Optimus Gen 3 can fit through standard doorways and navigate spaces designed for humans. The robot's outer shell combines lightweight plastics with strategic metal reinforcements, creating a design that's both robust and efficient. What makes these capabilities truly revolutionary isn't their technical sophistication, it's how they translate into real-world performance that surpasses human workers in many scenarios. Atlas is already working in Hyundai's Georgia factory, where it's handling tasks that are too dangerous, too precise, or too physically demanding for human workers. The robot can lift objects weighing up to 20 kilograms in each hand while maintaining perfect precision. It can work continuously for hours without fatigue, breaks, or loss of accuracy. Most importantly, Atlas can adapt to changing conditions, unexpected problems, and new challenges without requiring reprogramming or human intervention. In recent factory trials, Atlas completed assigned tasks 18% faster than previous benchmarks, while maintaining higher accuracy rates than human workers. When unexpected problems arose, parts that didn't fit properly, equipment that malfunctioned, or work areas that changed configuration, Atlas solved these problems autonomously and continued working. While Atlas is achieving these breakthrough capabilities, the competition is struggling to match even basic functionality. Tesla's Optimus, despite years of development and massive investment, still requires safety harnesses for many demonstrations and operates primarily through remote human control. China's most advanced humanoid robots, while impressive in their own right, lack the integrated intelligence that allows Atlas to work autonomously in unpredictable environments. Most competing robots excel at specific, pre-programmed tasks, but fail when confronted with unexpected situations or novel problems. What sets Atlas apart isn't just superior hardware, it's the integration of artificial intelligence that approaches genuine understanding. While other robots execute programmed routines, Atlas perceives, analyzes, decides and acts with a level of autonomy that represents a fundamental breakthrough in robotics. The secret to Atlas's revolutionary capabilities lies in its integration with NVIDIA's most advanced AI computing platforms. The robot runs on NVIDIA's Jetson Thor computing system, which delivers 800 teraflops of AI performance through next-generation Blackwell architecture processors. This computational power allows Atlas to process multiple data streams simultaneously: visual information from cameras, spatial data from sensors, proprioceptive feedback from joints and actuators, and environmental data from microphones and other sensors. All of this information is integrated through transformer-based foundation models that enable real-time decision-making and adaptive behavior. The robot's control systems operate through time-varying quadratic programs that solve 68 state variables at 1000 Hz, while direct drive motors close torque loops at 2000 Hz. This means Atlas is making thousands of micro-adjustments every second to maintain balance, execute movements, and respond to environmental changes. What truly sets Tesla apart in the robotics space isn't just technological capability, but manufacturing expertise. Tesla has already begun production of Optimus units at its Fremont factory, with over 1,000 robots assembled in the first quarter of 2025 alone. This isn't prototype production, these are the same machines planned for commercial sale. Elon Musk's pricing projections have consistently targeted the $20,000 to $25,000 range, with potential for costs as low as $10,000 once production reaches full scale. To put this in perspective, current humanoid robots from competitors typically cost hundreds of thousands of dollars and are primarily sold to research institutions and large corporations. Tesla's approach leverages the same manufacturing techniques that made the Model 3 a global bestseller. The company is developing assembly lines capable of producing 1,000 robots per month initially, with plans to scale to 10,000 and eventually 100,000 units monthly at next-generation facilities. This industrial capacity transforms Optimus from a research curiosity into a scalable consumer product. The economic implications are staggering. Musk has suggested that the total addressable market for humanoid robots could be 10 times larger than the automotive industry. With global labor shortages affecting everything from healthcare to manufacturing, autonomous robots capable of performing human-level tasks could revolutionize entire economic sectors. Tesla's confirmed Q4 2025 sale date isn't just an ambitious target, it's backed by concrete production milestones and regulatory preparations. The company has been conducting extensive real-world testing across more than 1,000 practical tasks, gathering data that feeds back into the robot's learning algorithms. Safety certifications represent a crucial hurdle that Tesla is actively addressing. Optimus Gen 3 includes multiple redundant safety systems, including dual battery backup, torque sensors that detect anomalies before they become problems, and fail-safe protocols that ensure the robot enters a controlled shutdown if any system malfunctions. The initial market strategy focuses on commercial and industrial applications before expanding to consumer markets. Tesla plans to deploy Optimus robots in its own manufacturing facilities first, using them to validate performance and gather operational data. This approach mirrors the company's strategy with full self-driving technology, where internal testing precedes broader market release. Now, let's switch gears to a surprising new competitor. Lenovo, known primarily for computers and mobile devices, just entered the humanoid robot race with their first model, Lexiang No. 1. At their Tech World 2025 event in Shanghai, Lenovo unveiled this robot with a dramatic demonstration performing a complete Tai Chi routine on stage. This wasn't just walking or standing, but slow, balanced martial arts movements executed live. During the Q&A session, the robot pulled data from Lenovo systems in real time and answered questions like a trained representative. Lenovo isn't just showing off technology, they're planning real-world applications. The company intends to deploy these robots in elder care and healthcare environments soon. And in August, they're bringing Lexiang No. 1 to compete in the Beijing Humanoid Robot Sports Games. Speaking of which, yes, the Robot Olympics is actually happening. Beijing is hosting the first humanoid robot sports games this August at two Olympic venues, the Bird's Nest and the Ice Ribbon. This isn't just a publicity stunt. The event will feature 11 human sports recreated for humanoid robots: track and field, football, gymnastics, and more. Robotics experts and sports professionals have collaborated to create events that mimic human movement as closely as possible. The goal is clear: refine mechanical structure and push motion algorithms further through performance under pressure. This is actually the second major robot sports event in China this year. The first was a humanoid half marathon in April, where 20 robots competed in a 21-kilometer race. One robot, named Kaiyang Kung Ultra, finished first after nearly 2 hours and 40 minutes. These events aren't just entertainment, they're massive benchmarks for stability, safety, and real-world readiness in complex environments. They serve as testing grounds for robots from different companies, validating their ability to operate outside controlled laboratory settings. Another robot making waves is called Atom, developed by PND Robotics in China. What sets Atom apart is its walking ability. It doesn't just move, it walks like a human, adapting its stride, balance, and pace on uneven terrain. This capability comes from its proprietary reinforcement learning system combined with imitation learning. In development since mid-2023, Atom has seen upgrades to nearly every component. Its legs and feet are reinforced for durability, and the actuators are modular for handling unpredictable environments. Atom runs on a full-stack system powered by an Intel i7 chip with real-time controls and full body motion architecture. It features 25 force-controlled QDD actuators, with legs delivering up to 360 Newton-meters of torque. The breakthrough capabilities demonstrated by Atlas represent more than just impressive technology. They signal the arrival of truly intelligent machines that can work alongside humans as capable partners rather than simple tools. Within the next few years, we can expect to see Atlas-level capabilities deployed across manufacturing, healthcare, construction, and countless other industries. The robot revolution isn't coming in some distant future, it's happening right now, and Atlas is leading the charge into a world where intelligent machines work alongside humans to solve problems, create value, and push the boundaries of what's possible. The age of truly intelligent robots has arrived, and everything is about to change. While the technological achievements are undeniably impressive, it's important to maintain realistic expectations about what Optimus Gen 3 can and cannot do. The robot excels at structured, repetitive tasks, but still struggles with complex problem-solving that requires human intuition and creativity. As we stand on the brink of Q4 2025, we're witnessing the beginning of a new era. The robot revolution isn't coming, it's here. And Tesla's Optimus Gen 3 is leading the charge into a future where the line between human and machine capability continues to blur in ways we're only beginning to understand. The question isn't whether humanoid robots will become part of our daily lives, but how quickly we'll adapt to a world where our mechanical companions are as capable, reliable, and ubiquitous as the smartphones in our pockets today. Looking at all these developments, the direction is clear. We're moving beyond the demonstration phase. These robots aren't just futuristic concepts or experimental prototypes. They're becoming useful tools ready for real-world deployment. The integration of advanced AI with robotics is creating machines that can adapt to our world rather than requiring us to adapt environments for them. From Unitree's AMO brain to Lenovo's enterprise-focused humanoid to specialized rescue robots, we're seeing practical applications emerge across industries. This isn't just about impressive technology, it's about solving real problems. Firefighting robots can enter dangerous situations without risking human lives. Humanoid assistants could help address labor shortages in healthcare and elder care. and the continuous improvement driven by competitions like the Robot Olympics pushes the entire field forward. We're witnessing the birth of robots that don't just execute pre-programmed tasks, but understand their environments and adapt accordingly. The line between programmed behavior and intelligent action is blurring, making this moment so exciting. So, what do you think? If you had a robot like G1 or Atom at home, what would be the first task you'd have it do? Let me know in the comments below. Thanks for watching, and I'll see you in the next video.